Okay, so I want to do the product rule in this video. So we want to take the derivative of the product of two functions. Say I want to take the derivative of like x squared times e to the x, right? So I know how to take the derivative of x squared. I know how to take the derivative of e to the x, but I'm multiplying them together. So which rule do I use or how do I do this, right? So that's what I want to talk about in this video. Before we do that, I just want to talk about the derivative of a single function. So just for notation's sake. So the derivative of f, let's say, is the limit as h goes to 0 of f of x plus h minus f of x over h. And if I look at the top here, this is how much the y value changes, right? So it's how much f changes. It's f at the right endpoint minus f at the left endpoint. So that's how much change there was in f. And so I'll write this as the limit as h goes to 0 of this delta f over h. So delta means change, okay? So this is shorthand for this, exactly what this is, okay? So I'm gonna use this. So this limit of delta f over h is the derivative of f. And so I'm gonna use this notation. Okay, so let's think about the derivative of this thing. If I use this notation, what it means is I want to take the limit as h goes to 0 of, well, it's the change in f times g over h. And so to figure out the change in a function, that's the change of this function. To figure out the change of the function, I need to figure out the beginning and the end, right? So I need to figure out what is f times g at the beginning, what is f times g at the end. So I'm going to use some geometry. To understand what f times g is, I'm going to think about it as the area of a rectangle. So let's assume that f and g are positive for now, but it works the same way if they're negative. It's just the intuition is a little messed up. So we'll just assume they're positive for now. So if I make a rectangle where one side has length f of x and one side has length g of x, then the area of this rectangle is f of x times g of x. So the area is f times g. So this is the value of my function at the beginning, right? So this is the beginning value. And now if I change x by a little bit, I want to know how does f times g change. So let's say I changed x by a little bit and f changed by a little bit, right? So maybe f increases a little bit. So this might be my f of x plus h. And so I can write this piece as my delta f. So that's how much f is changing, this little piece. And g might change by a little bit as well, right? So this might be changing by a little bit. And so this is my g plus g of x plus h. And so this little piece at the end is how much g changed. And now I can compute the area of this new rectangle. So the area of this bigger blue rectangle, this is going to be f of x plus h times g of x plus h. Okay, so let's write that down. So this is f of x plus h times g of x plus h. So it's the area of this rectangle, right? And I can compute this area in 4 parts, right? So it's sort of the original rectangle, this square, or this rectangle, and this smaller rectangle, right? So to compute them, I need to know the side lengths of them. And I actually already know all of the side lengths. So the original area of the rectangle was f of x times g of x. That's the biggest, smaller rectangle in here. Now the area of, let's say, this small, narrow rectangle on the right side, well, it has the base is delta g, and the height is f of x. So this is plus f of x times delta g. The same thing goes here. The height is delta f. The base is g of x. So this is plus delta f times g of x. And now this small rectangle has base delta g and height delta f. So this is plus delta f times delta g. And now I can use this to compute my derivative, right? So how do I compute the derivative of this? It's f of x plus h times g of x plus h minus f of x times g of x, right? So this is the limit as h goes to 0 f of x plus h, g of x plus h, minus f of x, g of x over h. And now I know this term. This term is exactly this thing right here. And I'm subtracting from it f of x, g of x. So I'm actually subtracting the first term from it. So this just becomes f of x, so it's still the limit as h goes to 0, f of x times delta g plus g of x times delta f plus delta f delta g all over h. And now I can break this into 3 separate limits. So it's the limit as h goes to 0 of, okay, so I'm going to write this as f of x times delta g over h plus the limit as h goes to 0 of g of x times delta f over h plus the limit as h goes to 0 of delta f delta g over h. Okay, and now we're in good shape because this term, the limit as h goes to 0 of this term, this is the derivative of g, right? If I take the change in the function over h and take the limit as h goes to 0, what do I get is the derivative. So this term that I've circled is the derivative of g. So this becomes f of x times the derivative g prime of x. So the derivative of g of x. The same thing, this term that I'm circling now, as h goes to 0, this is exactly the derivative of f. So this becomes plus g of x times f prime of x. And now to compute the third one, I'm going to have to multiply by 1. Okay, so I'm going to multiply this thing by h over h. So h over h here. And now if I take the limit as h goes to 0, this term looks like the derivative of f. This term looks like the derivative of g. And this is h, okay? So this is this thing plus the limit as h goes to 0, f prime of x, g prime of x times h. And now this term, okay, the derivative of f is something, the derivative of g is something, and now h is going to 0. So it's some number times something going to 0. So this term actually just goes to 0. So I can get rid of it. And so my derivative here is f of x times the derivative of g plus g of x times the derivative of f. And this is called the product rule. So I can use this to take the derivative of the product of any functions. So this is true for whatever the functions are, as long as these derivatives make sense.